Hi, this is Abhilash, an NLP engineer for HSBC, contributor for Google TensorFlow, and also Google Research, and a part-time instructor for Udacity, Udemy, and for Unity Technologies. So in this topic, I'm going to talk about low-dimensional embeddings in language processing. So in general machine learning practice, dimensionality is always a curse because what we try to prove in machine learning is to reduce the dimensions. So in the aspect of coming to the aspect of natural language processing, the dimensionality increases very much when you talk about large amounts of data. And simplified vectorization techniques like one-hot encoding does not do that much to solve that dimensionality issue. So in the one stage, we will be going to the different paradigms of embeddings, like going from what to vec, the traditional embeddings, which are static embeddings, which rely on neural networks, and then again we will be moving towards different aspect of embeddings which rely on transformer-based models, the long short-term memories, and then we will move into exponential embeddings. In all these different kinds of embeddings, the main theme would be to reduce the dimensions so that whenever we pass it through a dense network with different activations, we will get a comparatively smoother convergence and a faster convergence. Coming to the aspect of the contents of the delivery, there will be an introductory session relying on the standard models, traditional models like word to vec, and also its graphical counterparts, which encompasses all the algorithms and research-based materials concerning graph embeddings, node embeddings, and other variants of graph to vec, node to vec. So these are actually research-based materials which rely on extensive graph-based searching, such as line and harp, which are used for multi scalable data and high amounts of data, which also require large amounts of compute. In the next section, we'll be moving towards transformer-based models like Transformer XL, Elmo. We have BERT, Albert, Digital BERT, variants of different BERTs. And also GPT-2, GPT from OpenAI. So all these different kinds of models will be relying on long short-term memories and how they overcome the disadvantages of static embeddings. These type of peculiar embeddings are called dynamic embeddings, as they are more reliant and they have memory with attentions, which is greatly helpful for standard language processing or language models. Now, in the next topic, we'll be moving on to exponential embeddings, which is a rather different set of embeddings relying on statistical models with some basis kernels such as Gaussian, non-Gaussian, Bernoulli, and its derivatives. In these kinds of models, we will show the relation between how context vectors and word embedding sticks comes into play together. And the last section, we will be talking about a traditional theme of topic modeling, such as latent direct allocation and latent semantic analysis. While the latter, latent semantic analysis, is a positional attribute, the LDA will be more interesting to understand, and we'll be talking about different inference techniques in the topic modeling using LDA or its multivariate distribution. With all those, there will be different mathematical parts or intensive mathematical computations which will be done and which will be told, including WL, theorem, scale, divergence, and also Laplacian eigenmaps and different eigenvectors. So all will be done in Python, and hopefully I will be there to see you guys.